This video will cover how to set up a 3D character's movement using the new input system in Unity. More specifically, the camera will stay fixed but still follow the player, and the direction of the player will be based on the WASD keys. To get the new input system in your project, first we need to create a new project. So I'm going to call this movement tutorial. You can name it what you want. Make sure it's in 3D and click on create. Once we have the new project loaded, we need to go to window and then package manager. Now there will only be a few packages to start with, but if you click on advanced and click on show preview packages, let that load up. You can scroll down until we find input system. Now we want to make sure we install that, so click on install. Now when this warning comes up, we can just click on yes. Now once this has loaded up, if we click on edit, project settings, and go down to the player tab, if we scroll down and open other settings and scroll down until we find active input handling, we want to change this to the new input system and click on apply. Now this is going to reset your editor again, but it will make sure that it forces the new input system to be working. So the first thing I'm going to do is go to the project and we're going to right click on it, create input actions. I'm going to call this player input actions. Once we have this, we can double click on it. Now you may drag this somewhere so we can edit it. So I'm going to drag mine down next to the console. Another way to do it is to click on edit asset, and that will open it up too. Now this new input system uses a more visual way to understand and manipulate inputs from the player. So the first thing we will do is add an action map. So if you click on the plus, and we can name it player. Now this action map automatically comes with an action and a binding. So now we can rename this action. So I'm going to double click on it. I'm going to name it movement with a capital M. Upon selecting this movement action, there will be a set of properties that we can change based on how we want to interpret the movement. We're going to set the action type to pass through and the control type to vector 2. This is very similar to how you would manipulate a character using the old horizontal and vertical inputs. Now I'm going to delete this binding, and then if we click on the plus on the action, we can add a vector 2D composite. And I'm going to name this WASD. So in the properties section, make sure it is 2D vector and the mode is digital normalized. And if we have a look underneath it, we have an up, down, left and right. So by clicking on the up binding, we can see that the properties has changed. So the composite part is up, which is fine, and the path can be whatever you like. I'm going to set it to W on the keyboard. Now, if you're using a gamepad, you can set it to a gamepad path, but I'm not going to go through the setup of a gamepad in this tutorial. That is almost it for our player input actions asset. But the first thing we need to do is make sure we click on save asset. And once we've done that, go back to the inspector of the asset. Now we need to generate this C# class. So I'm going to click on tick and I'm going to click on apply. And what that will do is once it's loaded, it will add a player input actions class. We can use that to reference the actions inside of the code that we're going to write. Next, I'm going to create a player movement script. So right click, create C# script. I'm going to name that player movement. Once that is opened up, we can delete these methods for starters. Firstly, we're going to create a reference to our player input actions class that we have just generated. So I'm going to type in private player input actions, and I'm going to call it input actions. Next, we also need to store the movement into a vector. So I'm going to type in private vector2 movement input. Next, we want to create a speed variable that we can control in the editor, but we want it to be private so we can't access it from other scripts. So I'm going to type in a square bracket and type in serialize field, and underneath that I can type in my variable. So private float move speed, and we can set that equal to 10f. Next, we can create a private vector3 and call it input direction. We also want a private vector3 called move vector, and we also want to store a rotation. So private quaternion current rotation. The next thing we need to do is initialize our input actions. So we will do that inside of an awake void. So type in void awake, and inside the curly brackets, we can firstly set our input actions. So I'm going to type in input actions. We're going to set that equal to a new player input actions. Then we can set the movement vector from the input by typing in input actions dot player dot movement dot performed. And we're going to plus equal to context, and next to context we can type in equals to and greater than signs, and then we can set our movement input vector that we defined previously equal to our context dot read value, and the value is going to be of type vector2. This line reads the vector2 value of the input from the action callback, stores it in the movement input variable, and adds it to the performed action event. Now that we have that input, we can apply it to the player using a fixed update void. So I can type in void fixed update. Inside of here, we're going to define two floats, one called float h and one called float v. Now float h is going to be equal to our movement input.x, and float v is going to be equal to our movement input.y. Next, we will create a vector3 called target input, and we're going to set that equal to a new vector3. In the x value, I'm going to put in the h. The y value I'm going to type in 0, and in the z value I'm going to type in v. So this will calculate the movement based on the x and z values in the world. You can change the y value to whatever you like, but I will not be going over adding a jump to the character in the tutorial, hence it is left at 0. Now we will set our input direction variable equal to a vector3.lerp, and we're going to lerp from the input direction to our target input. We're going to lerp this over time.delta time, and we can multiply that by, I'm going to say 10f. Now I found that 10f is a nice number, but you are free to change it to whatever you'd like. Next, we will define a vector3 for our forward vector of the camera and the right vector of the camera. So I can firstly type in vector3 cam forward. We'll set that equal to camera.main.transform.forward. And we'll also have a vector3 cam right, which will equal to camera.main.transform.right. Now, the reason why we're setting these as vectors is because we want to make sure we set our cam forward.y equal to 0f and also our cam right.y equal to 0f. So we don't want to have them inside of our calculations. Next, I will create a vector3 called desired direction. I'm going to make that equal to the cam forward's direction. I'm going to multiply that by the input direction dot z, and we're also going to add the cam right vector, and we're going to multiply that by the input direction dot x, and this is the calculation of the direction we want to be going. Lastly, we're going to define a move function. So we're going to type in move, and we will take in our desired direction. Make sure your move has a capital M, like so. Next, we need to create a void move, which will take in a vector 3 of our desired direction. And inside here, we want to firstly set the move vector. So move vector dot set. We can set it to desired direction dot x. Then we want to make sure it's at 0. And our desired direction dot z. We can then set the move vector equal to the move vector multiplied by our move speed, and also multiplied by time dot delta time. And lastly, we can get the transform dot position, and we can make it plus equal to our move vector. Let's also set up a turn, so our player is able to turn based on the direction that we are moving. So I'm going to firstly type in turn with a capital T, and we will also take in the desired direction. Now create a void turn with a vector 3 for our desired direction. Now inside our desired direction, we're going to do an if statement, and we're going to check whether our desired direction is greater than or equal to 0.1 or negative 0.1 in the x and the z. And if it is, we're going to change the current rotation, and we're going to rotate. Firstly, I'm going to type in if, I'm going to put in 2 open brackets, and I'm going to type in desired direction dot x is greater than 0.1, and I'm going to type in the or, and we can type in desired direction dot x is less than negative 0.1, and outside of the first brackets we can type in or again. The desired direction dot z is greater than 0.1, or desired direction dot z is less than negative 0.1. And if any one of those things return true, we're going to store the current rotation as a quaternion dot look rotation, and we're going to set it to the desired direction. Then we will set the transform dot rotation equal to our current rotation. Else we want the transform dot rotation equal to the current rotation. So if we minimize this and head back into our editor, we can now create our player object. But first I want to create a plane. So if I go create 3D object plane, and we can stretch this out. We also need a player. So I'm going to create a cube, and I'm going to call this player. Now we have a box collider, which is perfect, but we want to make sure our Y is at 0.5 on top of the plane. And I also want to add the player movement script. So we can add that, and we have our move speed. Next we want to grab our camera, and we can't really see anything, so I might add a material quickly. So I can call this player map, and I might change it to red, and we can just add that to the player so we can see it in the game. Now I'm also creating a ground material just so we can see the ground better. And if we run that, we can see that it doesn't actually work. So if we head back into our code, one thing we need to add is we need to enable our input actions and disable our input actions. And we can do that in the onEnable and onDisable methods. So we can type in private void onEnable, and we can go input actions dot enable with a capital E. And then we can also have a private void on disable. We can type in input actions dot disable. So if we have a look at our game now, if we hold down our keys at the same time, and we let go of them one after another, we can rotate. It's sort of hard to tell with a cube. If you just press the key, doesn't really look like we're rotating that much, but we are definitely rotating. The last thing we're going to do is create a camera controller so we can follow the player smoothly. So I'm going to right click, create C# script. I'm going to call it camera controller. So let's open that one up. Now we're going to define some variables. So I'm going to type in vector3, and that's going to be our velocity. We're also going to have a public float, and this is going to be our smooth time. In the Z, also going to have a public float of smooth time, but in the X. And I will also have a public float of our offset in the Z. Okay, so you can set that offset to maybe -20f. Gonna have a reference to the player, so public game object player. I'm also gonna have a private vector3. This is gonna be our origin position. I'm going to set a private void start, and in our start void, I'm going to set our origin position equal to our current transform dot position. Now I'm going to have a void fixed update. So inside our fixed update void, I'm going to have a float of position X. I'm going to make that equal to mathf dot smooth damp. We're going to have that from our transform dot position dot X to the players transform dot position dot X, and we're going to reference our velocity dot X, and I'm going to type in smooth time X as well. Next I'm going to have a float position Z. I'm going to make that equal to mathf dot smooth damp, and this is going to be from our transform dot position dot Z to our players transform dot position dot Z, but we're going to add our offset to it as well, and we're going to reference our velocity dot Z, and this is going to be over the smooth time dot Z. Now lastly, we're going to set the transform dot position of the camera equal to a new vector3. We're going to grab our position X, our current transform dot position dot Y, and our position Z that we've created. So we head back into the editor. On our main camera, we can add the camera controller, and you can set the smooth time Z and X. I'm going to set them to 0.1, and I might move the Y back just a little bit. Might set it to 10. We also haven't added the player, so we need to add the player. If we go ahead and click on play, we can see we have our player, and we can see that we're moving around. We might have set our offset to a little bit too high, so we can set it to 10. So we got that around the center now, and we're moving along. If I set the plane to 10 by 10 by 10, you'll be able to see that we can move along towards the edge of it. Now in future I might do some more tutorials in this project, expanding on our basic player movement and camera controller, and we might make a game out of it. So if you like this, please be sure to follow along, subscribe, be sure to join the Discord server if you haven't already, and if you can, support me on Patreon. You don't have to, but it's all up to you. I want to thank you to Joshua and Benonis for supporting me on Patreon. So thanks guys.